we're going to explain the maximum call stack size exceeded error in Node.js. This error happens when a function calls itself too many times, creating a chain of function calls that's longer than what Node.js can handle. Think of it like a really tall tower of blocks. If you keep stacking them, eventually the tower will become too tall and fall over. 1. Understanding recursion. The most common cause is recursion, where a function calls itself. This is a powerful programming technique, but if not done carefully, it can easily lead to this error. For example, imagine a function designed to count down from a number. It calls itself, reducing the number by 1 each time until it reaches 0. If you start with a very large number, the function might call itself thousands or even millions of times before it finishes, exceeding the call stack limit. 2. The call stack. Node.js uses a call stack to manage function calls. Every time a function is called, it's pushed onto the stack. When the function finishes, it's popped off. The stack has a limited size, and exceeding that limit results in the error. 3. Identifying the problem. When you encounter this error, the first step is to pinpoint the recursive function. Check your code for any function that calls itself. Carefully review the function's logic to see if there's a condition that should stop the recursion, like reaching a base case, such as 0 in our countdown example. Sometimes the recursion isn't immediately obvious. It might be nested within other functions. Use a debugger, or add console logs to track the function's execution flow and identify the point where the stack overflows. 4. Debugging techniques. Use a debugger to step through your code line by line. This helps to visually trace the flow of execution and see where the function is calling itself repeatedly. Adding console.log statements at various points in your recursive function can also help track its progress and identify where the problem lies. 5. Solutions. The most straightforward solution is to fix the recursive function. Ensure it has a proper base case that stops the recursion. Sometimes a different algorithm altogether might be more appropriate. Instead of recursion, consider using iterative approaches, using loops, which often avoid stack overflow problems. Also check for unintended infinite loops. If you are handling very large data sets that might cause the stack overflow during processing, consider breaking them into smaller chunks to process in batches. This can significantly reduce the strain on the call stack. Remember, it's crucial to design your recursive functions carefully, ensuring they always have a well-defined base case to prevent infinite recursion and the dreaded maximum call stack size exceeded error.